objects, functions, and the execution context. Okay, so let's talk a little bit about JavaScript. And really, let's talk a little bit more even, let's get even a little bigger than that. So the browser, kind of like a car, and that car has parts to it, right? So let's start off with HTML. HTML stands for Hypertext Markup Language. HTML is essentially, if you imagine like a car, the body of the car, the structure of the car. When you look at a website, the structure of the website, where the header is placed, kind of maybe even the size potentially, if it's indented or bolded, those type of concepts can come from HTML. It's the skeleton of our page. Additionally, it's like the body of our car. We also have this other language called CSS, stands for Cascading Style Sheets. Imagine that this is kind of like the color of the car, the type of leather, the type of wheels, the styling. So the styling of your website, styling of the browser, that comes from this language CSS. But then we got this cool thing called JavaScript. And JavaScript is kind of like the engine of your car. It's what makes your website actually go. You know, clicking a page and getting, you know, when you, for example, are on a website and you click the nav bar, you open the nav bar, you click maybe the contact us page, and that takes you to a new page. How did that happen? How did you just go from where you were to now this contact us page? Well, a big part of that was JavaScript. When things actually happen, when there's actual functionality on your website or any website that you're interacting with, it's from JavaScript. And this is great. In the early days of the internet, all we had was HTML. You remember those, like, sorry for that banging, by the way, but you remember those, maybe you don't, but some of those older websites were just like, it's basically like reading a library book, but taking that page and just putting it on a screen, right? You were like, there's not really much I can do with this. It's just like really basic text. Then we got some styling, but then JavaScript came around, and then the internet became this amazing, beautiful place. Okay, so that's a little bit of history, a little bit about these languages. We're going to dive into JavaScript. We're not going to talk about HTML, CSS. We're going to talk about JavaScript. All right, so before I dive in, can I get a hands of who has come to like a workshop before? Okay, so, okay, great. It's like a lot of you. So as you guys are aware, we are going to be working on our technical communication as we go through this, right? So for those that don't know what that is, I'm here to guide you, be sure to be listening to other people as they kind of go through it. But we're going to dive in. We're going to look at this code that we have here, and we're going to think about it the same way that JavaScript thinks about it. And why are we going to do it that way? Well, because when we are continuing to code and our code gets more and more complex, in order to stay on track, to make sure we don't get lost in our code, we need to think the same way JavaScript thinks. The same way the engine, JavaScript has an engine, it's going to read your code. We need to be thinking the same way JavaScript thinks. So we're going to dive in. Okay, so before we begin, I just want to say this. We have something called the global execution context. I'll even rewrite it here. I'll do it. Okay. So we have the global execution context. The idea behind the global execution context is this. When JavaScript is reading our code, and this is how JavaScript reads it, kind of like a book, to be honest. Top, down, left to right. So we start at the top, we start at the left of each line, and we work our way to the right. When we get to the end of that, we go to the next line, like reading a book in English, for example. So wherever that code is being run is, and at the moment, in what's called our global space. Our global space is this most outer layer of code, like the most outer layer of where the JavaScript code is running. And we're going to learn as we move forward and we learn about functions, we can get even deeper. We can get inside of our global execution context. But the idea is that we have this global execution context. This is where our code will run. In addition, we have something called global memory. So when we store data and we store information, data is just information. When we store data, we need that data saved somewhere. Where does that data get saved? It gets saved in this place called global memory. Okay, we're going to do this. We're going to dive in. I'm going to start with Jennifer. Jennifer, can you walk me through line 1?
Sure. We're going to declare a variable called mygrades and assign it the value of, the value of an array with three values, 50, 75, and 100.
Okay, so excellently said. Jennifer, where are we storing this?
In the global memory.
Okay, great. So as Jennifer said, we're going to declare a variable. It will be equal to an array, which is an array of, Jennifer mentioned 3 values. We could also say 3 elements, 50, 75, and 100. And I guess we'll go to the next line. Jennifer, also go line 2.
Sure. So we're also going to declare a variable called sum and assign it the value of 0, and that will also be in the global memory.
Excellent. Now, Jennifer, let me ask you a question. There's a little bit of a difference between line 1 and line 2 in terms of how these variables were declared. What is that difference?
The keyword is const versus let.
Okay. So I'm going to pause for 1 sec, Jennifer. Excellent job. So Jennifer mentioned we have these 2 variables. Variables, all they are just basically names, ways we can reference this information. We have my grades. It's like a label. A label. That's probably another way to say it. Label, it's equal to an array with the elements 50, 75, and 100. An array is just a way we can store a bunch of information. So we have this array, which we have these brackets here. You see these brackets. So brackets, that means an array. An array just, and by the way, for this array, an array is just a data type that can store a bunch of information inside of it. So this array has 3 things inside of it. What are those 3 things? Those 3 elements are the numbers 50, 75, and 100. But Jennifer mentioned something. On line 1, we declared this variable with const, but on line 2, we declared it with let. Now, what is that about? Jennifer, do you have an idea of kind of const versus let?
Okay, so maybe const means it can't be changed.
Yep, so const can also be, const is like a short name for what word?
Constant.
Constant. So const is a constant. Const, when you declare a variable with const, C-O-N-S-T, const, what it tells JavaScript is whatever value I assign to this variable, whatever value I assign to this label can't be changed. You can't reassign it later on. Whatever I assign it at my initial declaration is what it must stay the whole time this variable is, in memory. But
Reid.
Jennifer, what about let?
Oh, I was going to say, but can't it be modified?
Well, it can't be modified. I know where you're going, but we'll get into that later. But what about let?
Let can be reassigned.
Totally. So Jennifer brought up exactly this point, and thank you so much, Jennifer. I really appreciate your help. So let tells JavaScript, hey, I'm going to declare a variable. I'm going to call it, in this case, sum. I'm assigning it the value of a number 0, but honestly, later on, if you want to totally change the value, go right ahead. Let just says, basically think of it like this. Const is constant. You can't change the value stored at that variable. Let means I'm letting you change it. You can change it to whatever you want later on. So you may sometimes see something like var, by the way. If you ever see var while you're coding, var is another way to declare a variable. However, this is important. In 2015, JavaScript had a massive update. It's called ES6, Ecmascript 6. It's just a big update to JavaScript in 2015. And in 2015, const and let came around, and we downgraded var. var, I'm not going to go into why, but var has some built-in problems with it that can make your code messy for bad reasons. We don't use var. I don't care if you're going out there and you see people using var and you're like, they use var and they're like, they've been coding for 20 years. They're outdated. That's what that means. We don't use var anymore. We use const or let in JavaScript. So just a heads up, we don't declare variables with var. Okay. All right, so to recap, we have declared a variable myGrades and stored it in memory as an array, those brackets, with the elements 50, 75, and 100. We also then declared a variable sum, and we set it equal to 0. Excellent. Next up, Gustavo, can you walk me through line 3, please?
Okay, let's assign an array
For line 3?
for line 3.
Okay, no worries.
Oh.
You're saying about the bracket next to it?
The sum, right? For line 3, we're talking about?
Yeah, so the sum is equal to what?
Okay, sum is equal to myGrades
Mm-hmm.
and our rate of 0.
Okay. Okay, so Gustavo is touching upon a good point, which is this. And this is excellent effort. We're going to go through this line, Gustavo. I just wanted to see, I kind of tricked you into kind of saying the thing I wanted you to say, to be honest. Okay, so Gustavo just said, I'm going to take sum, and I'm going to set it equal to myGrades with an array of 0. Now the question is, an array of myGrades array of 0, what does that mean? Okay, so firstly, let's start with this. Gustavo, where does myGrades, the variable name myGrades, sound familiar to you?
Yes.
Right, and why is that?
Because has already been assigned.
Mm-hmm. Exactly, because we declared a variable earlier called myGrades.
Right.
So, okay, so at least we now have an idea, a reference of, okay, we know they're probably talking about something to do with this array we made earlier, but what's going on with this? So people, this is something interesting you're going to learn about coding right now. So that bracket with a number next to it, that's right next to that variable name, myGrades bracket 0. What does this mean? What this tells JavaScript is it goes, okay, JavaScript, I want you to do this. I want you to go look in memory and see if there's some variable called myGrades. Let's check out, is that the case? Okay, thumbs up, we got that. And now I want you to return to me the bracket 0 element. Now what does that mean? All right, people, here we go. This is exactly what that means. Coding, not just JavaScript, coding in general, when it comes to things like arrays, are what's called zeroth indexed. So you might be thinking, if we look at this line right here, you might be thinking, okay, 50 is the first element, 75 is the second element, 100 is the third element. That would be pretty intuitive to us, right? First, second, third. No. We don't get to be that easy. We don't get to be that easy. Coding thinks of it like this. 50 is the 0th element, 75 is the first element, 100 is the second element. So in coding, it's 0th indexed. We don't start 1, 2, 3 when we're talking about an element in an array. We start 0, 1, 2. I know, I don't know why. I'm sure there's a reason that's far above my understanding, but that's how it works. So now, Gustavo, let me ask you this. If we're saying here, hey, go to look in memory, see if there's a variable called myGrades. Return to me the element that's at the 0th position. What value are we now asking to get?
So we're asking to return the value of 50.
Exactly. So where it says myGrades of index 0, it's really saying what, Gustavo?
it's really, okay, can you repeat the question again? I'm sorry.
No. So it's saying, it's kind of what you're saying. It's saying really 50.
Right.
So then let's keep going, Gustavo. What does the next section of that line say?
The next section of the line is to return the value of 1, which is 75,
Keep it going.
and the value of 2, which is 100.
Exactly. So what this is, thank you, Gustavo. So what we're really saying here is this. Sum is now equal to the value at the 0th index of my grades plus the value of the first index, position index, same concept, plus the value at the second index of my grades, which is again the same thing as saying 50 plus 75 plus 100. So sum is equal to 225. Okay, now people, check this out. Earlier we said sum is equal to 0. We're now saying sum, right? We didn't even declare. We're reassigning what sum is, and we're saying sum is equal to 225. Ronald, let me ask you this. Is JavaScript going to be okay with me going in and changing the sum from 0 to 225?
Yes.
Yes,
No.
it is. It was a good indecisive guess. I like that. But why? If you can try to give me a little bit of a why, JavaScript will say, oh yeah, you could totally reassign sum.
Well, because we use the let keyword.
A round of applause, everyone. Exactly. Because we had declared sum with let, we can now totally change it to whatever we want it to be. We can totally reassign it. Thank you, Ronald. We can totally reassign it. It's all good. The JavaScript's like, oh, let me check. Oh, you used the let keyword. Yeah, no, you can totally reassign that. Okay, great. So sum in memory was 0. It's 225 now. Okay, let's keep it going. Here, let's keep it going. Ronald, let's go to the last line here, line 4. So walk me through this line.
It's going to be, I'm declaring a variable average.
Mm-hmm.
Assign the value of sum divided by mygrades.length array.
Okay, so then let's start with this. Where is average going to be saved? Where on this kind of screen?
Oh, the average is going to be saved on the global memory.
Exactly. Okay, so we got average.
Average.
I spelled that wrong. Average. But okay, we don't know what average is equal to yet. That's fine. So we say average is equal to sum divided by, for those that don't know, that is an arithmetic operator for divided by. This mygrades.length. Okay, so let's start here. Ronald, so JavaScript is going to say we're declaring average. Let me ask you this. Well, I got to go here. It's going to say sum, and it's going to look in memory, and it's going to try to find sum. Ronald, do we have something in memory called sum?
Yes.
And what is its value?
225.
Okay, cool. So really, this is kind of the same thing as saying 225. But now we're trying to find the mygrades.length. Now, people, this is what the dot length means. Arrays have a built-in property on them called length. And all length does is tell you the number of elements inside of the array. So, Ronald, if we're going mygrades.length, which is the length of the mygrades array, or the array stored at mygrades, what is the number that will get returned?
3.
Exactly. So this would be 75. So average is equal to 75. And now last question, Ronald. If I wanted to now say average is equal to 1,000,000, could I do it, or would JavaScript be mad at me?
You could, because we're using the let.
Exactly. because we are declaring average with let. So if I wanted to, for example, on this line right after it, say average is equal to, I don't know, 1,000, JavaScript would be totally fine with that because I used the let keyword when I declared it. If I had used const, this would be not chill. Literally, JavaScript would be like, you use a const declaration. You don't get to reassign it now. Duh, you know, so we're good. We get it, right? Let, you can reassign const, you can't. Okay, cool. So, all right, people, let's stop for a sec. We just went through a couple lines of code, the way JavaScript would have thought about it. The way we just went over this is exactly the same way JavaScript would have thought about it. So great, we're learning, we're declaring variables, we're assigning values, we're storing them in memory. We have our global execution context where we actually execute some code. We are learning about how can we access certain elements inside of arrays via the index, which is 0th indexed. We then will learn about the length property, which is on arrays, which tells us how many elements are inside of an array. Okay, cool. We're going to keep leveling up. We're moving forward. Okay, now that was cool. That was great. But let me ask you this. What if we wanted to kind of use the same code again and again, right? Over and over again. What we did before, we couldn't do that because JavaScript starts at the top, goes to the bottom. That's it. You can't just tell it, hey, JavaScript, wait. Can you start over? Can you go back to the top? It's not how it works. How can we do that? Well, we utilize something called functions. Functions, really all they are is just a set of instructions that when you say, hey, run this function, what you're saying is perform these set of instructions. So functions are declared with the function keyword. Do you remember how earlier we had const, we had let? Those were ways we could declare variables. Function is a keyword to tell JavaScript you're declaring a function. The next word after it is the label of that function, just like there was the label for the variable. You don't need to worry too much about these parentheses at the moment, the one that come right after average grade. We'll talk about that in the next slide, maybe. We then have these curly braces. And whatever is inside those curly braces is called the body of the function. It's the actual code that will be run when you tell this function to go. Now, let me ask you this. How do we get a function to go? How do we tell a function to run? How do we invoke a function? Is another way to say how do we invoke a function? We do that with parentheses. If everyone can look right here and right here, these last two lines, do we notice how we say output is equal to average grade parentheses, average grade parentheses? What we're saying in that instance is go actually run the function. Go run the function. We're going to dive into this. We're going to technically communicate. We're going to show you exactly how JavaScript does all of this. But that's the idea. When you see the name of a function or honestly the name of a variable and parentheses next to it, it's telling you or telling JavaScript, run this function, run this set of instructions. Okay, we're going to dive in. So same thing, we have our global memory, we have our global execution context, but now we have another little extra spiciness to this, and it's called our call stack. And our call stack, all it is really is a stack. Here, let me draw this out. That just helps JavaScript keep track where it is currently. So normally, right now, we're in what's called global. Global is like our outermost layer of code. And we're going to learn how do we get to a deeper level of, a deeper execution context. But right now, it just tells us, hey, you're in global. You're in the global space. So we're going to go through this. We're going to kind of try to get through this section here. All right, so Cesar. All right, man. Try. Okay, here we go. We're going to start line 1. So walk me through what's happening line 1.
So you are I guess, declaring a function called average grade.
Uh-huh.
There's no, well, parameters in there.
Nice. Good job.
And then inside the body, the curly braces,
Uh-huh. So I'm going to pause you for a sec. So we're gonna think the same way JavaScript does. We're going to think the same exact way JavaScript does. So we'll start here. Let's backtrack. We're going to declare a function called average grades. Where does that get saved?
in the global memory.
Yes. All right. So let's do that. Now let me ask you this, because you're about to enter the body of the function, but I'm going to ask you, what gets saved in memory? What does average grade equal to in memory? And
What
totally
gets-
okay if you're not sure.
What gets saved? The things that are inside the body, I would say,
Okay, so it's a good guess. It's a good guess.
but nothing at the moment. I don't think.
Yes. So there will be something saved at the moment. It's what's called the function definition. So here's the thing. This is how I kind of label the function definition. So our man here, Cesar, was about to enter the body of the function. He was about to go, okay, we got our function average grades as no parameters, which we'll talk about in the next slide, but you know, those curly braces right next to average grade, that's what he's kind of talking about. And then we have these curly braces, and he was about to go into the body of the function, but here's the thing, because we're thinking the same way JavaScript does. When JavaScript sees a function, and it's been, well, you know, I see the function keyword, I see this is a function, it actually does not even enter the body of the function until you tell it to be invoked. Until the moment you tell it, hey, JavaScript, I want you to actually run this function, it doesn't even look inside the body of the function. What it does is it saves its function definition. What that really means is it saves kind of the set of instructions in memory, but it doesn't actually enter the body quite yet. So Cesar, off of that, let me ask you this. If we're thinking the way JavaScript has, we have this function. We declare a function average grade. We've stored in average grade in global memory. We've stored its function definition. What is the next line that JavaScript would go to?
Well, since it's not doing anything until it's invoked, it goes to the const output equals average grade.
Exactly. Exactly. The way that JavaScript works is when you declare a function, it saves its function definition in memory, but it doesn't actually enter the body of the function. So what would it do? It would go to the next line after the function, which for us is this, you know, this one right here. Const output equals average grade, invoking average grade. Okay, so let's hit that line. So Cesar, walk me through that line.
So you're assigning output to a constant.
Yep.
Variable that's going to equal to average grade, and because you have the parentheses, whenever I guess you call output, it's going to invoke the function and loop back around to the average grade and run the body.
Okay, so not quite. Good guess. Not quite. So let's start here. We're going to declare a variable output. Where is that going to be saved?
And the global memory.
Exactly. And so we're telling it right on that line there with those parentheses, I want you to run average grade. I want you to invoke it. I want you to go. And so what we're not telling it here that, oh, we're saving average grade to output, and when we invoke output, it will then run average grade. What we're doing is we're saying output will be equal to whatever gets returned from when we run average grade. So what we're going to do in this moment right now is we're going to run average grade. We're going to invoke it. And then whatever gets returned gets saved at output in global memory. But here's something important. While average grade is being run, while JavaScript is going through that body, finally going through the body of average grade, output will be equal to undefined. Okay, so in the meantime, output is equal to undefined. Until we get any information back from our function, output is equal to undefined in memory. All right. Thank you, Cesar. Appreciate it. Next up, Josh. So we're invoking average grade. Okay. So I want to make it clear before we dive in. We have two big things that are about to happen when you invoke average grade. We're going to, well, let me ask Josh, have you gone to a easier or intro to JavaScript before?
No, I've just done the first two
Okay.
CSX
Seconds.
units.
Okay, so I'm going to explain this part. So when you invoke a function, a couple things happens. Firstly, you're going to what's called push a call frame to the call stack. So remember I told you the call stack tells JavaScript where exactly it is. Where is it currently operating? It was operating in global, but now it's going to be operating inside of average grade. It's a frame that we put onto the call stack. The way the call stack works is whatever is at the top of the call stack is where JavaScript currently is operating. So people use the analogy of like pancakes or like a stack of books or a stack of plates. The idea that whatever is at the top, you can't just open up the middle, pull out the middle, and close it. The way it works is if you want to get to the bottom, you have to pull off if you want the most bottom book, you have to take the top book off, move that to the side. Take the top keep taking the top books off until you get to the bottom. It's the same way with the call stack, and we're going to dive in and show you kind of more what that means. But
it's like higher order function.
It's not a higher order function. A higher order function just means a function that you can pass into another function. But it's just another way of saying, hey, JavaScript, right now I want you to be working on the average grade execution context. So we had our global execution context. That was the most outer layer.
Mm-hmm.
When we invoke a function, we create what's called a local execution context. I will draw that out. This is our local execution context. And the local execution context has its own local memory. So what we're doing here is we're now kind of creating a subspace in JavaScript to kind of run through our function. And this is average grade. So Josh, we've created our local execution context. We've added, and how does JavaScript know it's going to be working on this average grade local execution context? What is telling it, hey, JavaScript, you should be working on average grade?
Const output.
Not quite. I mean, that eventually leads to it. Const output invoking average grade. But what tool here do we utilize that tells JavaScript what it should be working on at that moment?
The local execution context.
Good. So we have the local execution context, which is where our code will be running. But there's one more thing here, the call stack, right? The call stack tells JavaScript what it should be. Whatever's at the top of the call stack is telling JavaScript, this is what the space you should be working in. So right now we have average grade at the top of the call stack. We push that on. When you add a call frame to the call stack, it's called pushing. So we push on a call frame to the call stack. Whatever's at the top is telling JavaScript, hey, this is the thing you should be working on right now. So average grade is at the top. All right, Josh, we're now inside the body of the function. Walk me through the first line inside the body.
I'm sorry, I'm still like kind of trying to understand call stack, global execution context, and global memory.
Sure.
So call stack is basically the prioritization of the functions, or right?
Yeah, it's
It
basically
just basically
the
tells the JavaScript.
prioritization. It tells JavaScript what execution context it should be working in.
Mm-hmm.
So
Okay.
right now it's telling it to work in the average grade execution context, which is this done right here.
And does global execution context and global memory share the same relationship that like computer RAM and hard drive space share?
Not, I guess a little bit kind of like that. Yeah, I mean, basically JavaScript has some built-in memory to it. It has what's called a V8 engine, but I don't want to, I think it's a little off topic. So, but the idea is, yeah, it basically is the equivalent of like RAM and hard drive.
Okay, gotcha. So I'm sorry, what was your question?
So let's enter the body of the function. Let's go over the first line in that body. So we're on line right here.
Okay, sure. Well, it's an array. I'm not sure what.
So, right, we work on our technical communication. So what are we doing? We're declaring a variable.
Is const also known as a variable? I thought it was just let.
No, so const is constant, right? Const means you can't change it. Let means that you can.
Right.
So const totally means you can declare a variable.
Okay.
All right, so all good, Josh. I think it's a little bit disconnect. That's fine. We're going to move on. So Sohi, why don't you kind of pick it off where Josh was, and we're on that line right there.
Okay, so we're declaring variable migrate with const.
Yep.
And assign values in an array of 3 elements.
And what are those elements?
50, 75, and 100.
Excellent. And so now, Sohi, here's kind of the trick here. Where is it going to be saved?
I would say memory.
Okay, excellent. And now we've got two, right? We've got this global memory, and we've got this local memory. And my question to you, Sohi, is what execution context are we currently in?
We're in local execution context.
Exactly. So people, this is important. Whatever execution context you're currently in, that's where you're going to store, well, that's the memory you're going to utilize when you're storing variables in that execution. So as Sohi said, we're going to declare a variable myGrades and set it equal to an array with the variables 50, 75, and 100. So that's what this looks like. We're inside of our local execution context. Let's look inside of our local memory. So we're going to declare a variable called my grades, and this will be equal to an array of 50, 75, and 100. Okay, so let's keep going. Let's go to the next line.
Okay, so we're declaring variable sum with let equals 0.
And where are we storing and saving that?
Local memory.
Exactly. Oh. Okay. Sum is equal to 0. All right, let's keep it going. So let's go line 3.
Okay, so then sum equals migrates value of 0 index.
Yep, so the index, so my grades at the 0th index.
That would be 50. Plus value of the first index, which is 75. Plus value of the second index, which is 100.
Excellent. Okay, so sum is equal to 225. And so let me ask you this. If I go in and I change from sum from 0 to 225, is that going to be okay? Will JavaScript be mad at me?
No.
And why not?
you. Because we declare sum with let.
Exactly. All right, we're going to pause for a second. Shukri, I see you have a question.
I had a question, but then you continued working through because I was just confused by, how we just wrote under the local memory that the sum was equal to 0.
Yes.
And then you started writing out the expression of sum on on the other side, but then it made sense as to what you just did now because it just
Reassign.
I got it. Thank you.
All right, awesome. Great. Glad. All right, sweet. So, all right, so we have here, so he keep it going. Let's go to the next line.
So let sorry. Declaring variable average with let equals sum, which is 225 divided by migrate.length. It's I don't know how to explain that. It's like divided by 3, but I don't know how to put that.
No worries. Okay, so Sohi excellently said. Let me ask you this: where are we storing average? Where is that going to be saved?
Local execution context.
And specifically,
Local memory.
Yeah, local memory.
Yes.
So migrate.length, you said 3, but what is that? That's the what? 3 is how many what?
Of the values of migrates, the arrays.
Exactly. So it's just how many elements are inside the array.
3.
Exactly. So the length property, right, tells us how many elements are inside the array. As Sohi excellently said, this is basically the same thing as saying 225 divided by 3, which is 75. Okay. So now, Sohi, this next line here, this final line is such a vital, so important. So firstly, just say out loud, what does that final line say?
Return average.
Okay. So it says return average. Okay, well, we know what average is, right? Average is what value, Sohi, at this point, at the end here?
75.
75. So the return keyword for everyone here, what the return keyword says is take like whatever comes after the return keyword, take that value and return it to wherever this function was called. So let me ask you this, Sohi. If we look at this block of code here, what line did we actually invoke average grade? What line did we actually call average grade?
Function?
Yeah. Well, yes, but what line did we do that? Did we tell it to run, tell it to go?
What line?
Yeah. What line in this, whole block of code, what line is actually saying, go run this function, go actually tell this function to go?
Is that the very first line?
Not quite. All good. Let's see. Excellent guess. Again, I'm so sorry. Asar, is that correct?
Yeah, hey, can you hear me?
Yeah. Okay.
Yeah, that's correct, yeah.
So do you have a guess of what line we said, hey, go run this function, actually enter the body of the function? What line is doing that?
Is it like line 7 when we invoke
Exactly.
average grade?
So, which is this line right here.
Yeah.
So right, and you're spot on. So we're saying on line 7 where it says const output equals average grade, what we're saying is the kind of technically communicated way is, declare a variable output, assign it the value of the returned evaluation of invoking average grade. Another way you could say is whatever gets returned from, invoking average grade, telling it to run. So Asar, we now have this keyword. It says return average. So let me ask you, where do we think, and we know average is equal to what?
75.
75. So this is also kind of the same thing as saying return 75. Where do we think 75 is about to be returned to?
I'm gonna guess the global memory.
Global
Or the-
memory, and specifically where at the global memory?
Oh, the global execution context? Or
But there's somewhere in memory right now that we can see in global memory that we should return this value to. So right now, let me ask you this: let me backtrack.
Mhm.
What line? So you said line 7 we declared we invoked average grade, right? We set it to
Mhm.
run.
Yeah.
What did we assign this to? What did we assign what would be returned from average grade to?
We assigned it to the variable output.
Exactly. So let me ask you again, where do we think this value will be returned to in global memory?
The variable output. I
Yeah.
mean,
Yeah, to output, right?
yeah.
That's where we invoked it. We said, hey, here's this variable output. I want you to invoke average grade, and whatever gets returned, save that as output in global memory. So this 75 will be returned to output. So now what was once undefined, output will now be, oh, whoops. Let me make this a smaller and easier. Output will now be 75. The return keyword says, hey, wherever you called me, wherever you told me to run, I want you to take whatever comes after the return keyword. So in this case, we said return average. It would look in memory, say average. What's average? Oh, well, I see in local memory, average is 75. So return 75. Return it where? To wherever I was called. And where was I called? I was called on, in this case, line 7, this variable output, save output in global memory. It's undefined until I get some value back from this function. What value did I get back from this function? In this case, I got back the value 75. So now in global memory, if we were to check out, hey, what value is stored at output at this point? It would say 75.